describe this thing. So, why do we care about DCI? So one of the problems that we're trying to solve here is we've got these concepts. This idea of what the system is, which is usually centered around state, but also around mental concepts of things like users, staff, accounts, things that are important to the business, and what we want the system to do. So these are the behaviors we're modeling. So does anybody do sort of behavior-driven development kind of stuff? Or if you're an agile Scrum person, user stories and stuff. So you're trying to describe these behaviors. You've got these scenarios. Features come down, they have scenarios, you're breaking them down into behavior, and then you're going to write algorithms about what the system does. And you're going to do this over and over and over again, right? Software is never finished. You're going to keep doing this, but often those objects that you started with, those data objects like account and user and stuff like that, those don't tend to change much. You might add a couple here and there, but what they are is not a concept that changes mentally. And most people don't describe a system all that much by what the things are, but by what they do. And I'm going to sort of give a couple examples that show that. But first I just wanted to talk a little bit about object-oriented programming. I mean, we all love object-oriented programming, right? I mean, it's a little challenging at times when we have some, there are things that don't always go so well. Inheritance is a bit fuzzy, and sometimes you get a bit tired of it, but that's okay because you can always do that, right? That's fine. And then there's this other guy, right? He comes to these meetups, meetups like this, and he's all like Erlang, and so yeah. Anyways, I think we can all agree inheritance is fucking awesome, right? I mean, you've got Dragon, and then you're all solid, bra, right? So you've got your open-close principle. You're going to extend Dragon, and then some other guy comes along. He's going to extend your Dragon, and then Nintendo comes along, and they just won't let the fucking thing die. And of course, Liskov, right? You got to have Liskov. What the hell is the point of that iDragon anyways? Sorry, I realize some people probably can't see, right? I'm standing like right in front of the jokes. Sorry. So, anyways. Inheritance. In case you're wondering where you'll find the iDragon interface too, you need a little arrow. So, anyways, this is really the problem that I think Trygve and James, if you watch the videos on DCI, this is the problem they're really trying to get at is some of the ways in which we do OOP. There's good things about it. It gives us this idea of modeling, of encapsulation. The solid principles are all really very good, although they have really very little to do with object-oriented programming itself. So what they wanted to do was find a way to try to start decomposing some of the complexity and spaghetti code that was coming out of OOP. So as an example, like just trying to bring this through to something real world, if you do Rails or if you do any sort of MVC, you've probably heard the skinny controller fat model idea, right? So skinny controller fat model is pretty straightforward. It's basically the idea your controller is responsible for one very simple thing, and that is handling the requests and returning a response, right? It's essentially a middle piece between the view and your model. So if it's only responsible for that one thing, it's all really good and SRP and solid and everything, and you can add new routes in separated pieces, then where's everything else, right? Well, the model is everything else now, right? And obviously everything else, I can say that all at once, so it's a single responsibility, so we don't really have any problems here. I can pretty much finish the presentation here because there's obviously no problem with that. So that's a bit unfair because that's not actually what they mean by skinny controller fat model, but they do mean that the controller has a very simple responsibility, and in the end, the people who've designed Rails, the people who are, the Rails responsibility kind of ends there. It gives you active record at the model, but nobody, everybody says, well, your model's not one class, that does everything. Nobody really talks a lot about how you should build models in Rails, or they're only just starting to, or any other MVC framework. They don't really deal with that. It's just left out there. Oh, and then there's the model. So part of the idea of DCI is to try to start describing that and decomposing the model. And so they decompose it into three parts. There's actually four concepts here to understand. The data is our representation of what something is. So we really only care about describing it. It's very dumb if you want to look at it that way. It's typically your active record, active model stuff. I do apologize. I know not everybody loves Rails, and it's not meant to be Rails-centric. I'm just sort of, I think most people are familiar with it. There's the context, right? So the context is literally what we're talking about. It's a way of creating a context around a scenario or a business problem, some sort of action that we want to perform in the system, and it's a single point of reference to understand and reason about what's going to happen in that context. There's interaction. Those are the behaviors that we want to model in the system. And then there's roles. So roles are important. I just want to describe them because really we're going to talk about data, context, and roles. The roles encapsulate the interaction, and that's actually what the decomposition is. I don't know why they called it DCI, but that's what they did. So let's talk about data. So data, as I said before, just defines what a thing is. Basically, we're talking about a simple, I'm just going to move this here so I can get a little closer, persistable representation of useful state. And the important thing about what we're trying to do here is we don't want our data to do anything that limits what we can choose to do with that data later on, because we're going to change our minds. There's going to be new business requirements. We want to be able to do that. So what's data look like? So can somebody tell me what's the most ubiquitous class in software development and in software and building an application? A class you probably have in every application, other than program.cs or main or something.
Repository or something?
Object.
User.
Object, yes.
It's going to be user. Maybe account sometimes, maybe staff, but generally speaking, it's user. Like some person who's going to use the system, who needs the system to know about who they are. So what's a user, right? So this seems like a reasonable description of a user. You probably have other things that are important. I'm not entirely sure why height and weight need to go with username and password, but we care a lot about this person. It could be an exercise tracking application. So what can a user do, right? Like what are things a user can do? This is pretty much where you're going to go next. I'm not entirely sure why there's a delay there, right? Log in, log out, right? So we've already started adding some kind of boilerplate stuff to the user that every system has, but that's not really what we care about. So, what's something that you can do, like that you would want to describe in a system? Like what's something that you personally can do? Think about yourself as, as something that you are a user, you are a person. But what is something you can do? So, me, I can brew beer. Oops, that's what I get for using this potential thing. Right? Screw you. All right. I can brew beer, right? So this is this is also showcasing another one of the things that I'm really good at and that I can do, which is write horrible code. So ignoring the desperate need for refactoring here, this is my beer brewing algorithm. This describes brewing beer to me. So if I had a system and I built it and I'd added this to it, this is what I would want to see to understand what happens when somebody executes brewing beer in the system. So, as a result of brewing beer, and brewing beer mostly involves, a lot of equipment and drinking a lot of homebrew in the middle steps. It is crucial to the process, okay? As a result, though, I'm going to need some helper methods. I'm probably going to gain some weight from drinking the beer. And, I might try to implement the lose weight method. It does appear to be not yet implemented, but, we're working on it. So this is going to go on and on. There's going to be all these things that I'm going to want to do within the system, right? Like think about all the things. So, when somebody asks if you're a God object, come on, guys. You say yes, right? So, think about it for a moment. This gets painful. It's tedious. Like how do you keep this stuff organized? So for DCI, the answer is the roles. We can create roles. So rather than reasoning about what something is and then saying, well, these are the things because you are a user that you can do, let's talk about what role you're playing when you do it. So a role essentially defines what one of our objects can do when acting within a specific context, right? It acts that specific role. So things that I can do. As a home brewer, I can brew beer, right? As a developer, we've already seen that, I can write ugly code. As a user access account, that's not a great name, but I can log in and log out. As a man, I can pee standing up, but I am a Twitter user, so I tend not to. So, So here's a role, right? This is what this looks like in DCI. This is pretty much your bread and butter. Some of you are going to, especially if you know how Ruby's extend works, you're going to wince and probably stop listening to me at this point. But you create a module, right? And so this module is just my way of encapsulating what it is a home brewer needs to be able to do, the algorithms related to being a home brewer. These are the behaviors, and I've attached them and I've got some context around them. This is a bit nicer for me. It's a bit easier for people to understand what's going on. I can inject this into the user when I need the user to act as the home brewer. I can tell it, you're going to be a home brewer today, and I want you to make a Dunkelweit. And so that'll hopefully happen, depending on how many homebrewers are drunk during the session. So let's use some examples that actually make sense for coding. So essentially, okay, all right, sorry. This is just sort of reviewing where you can do roles. So that was an example of roles with mix-ins. If you take a look at some of the source material on that, it's actually commonly called by Copeland and Trygve traits, and they use traits in Scala, the actual feature in Scala. They've also done it, they originally did it with C++ templates. I don't know why they did that, but amazingly it works in C++. It looks like, from the code I've seen, it works fairly well. Interestingly enough, it does not work at all in Java. There's like some weird extension work to make it work, but out of the box you can't do this. And it's largely, as they say, because nobody really considered doing OOP this way when these languages were created. But again, our main goal here is we want to write code in a way that models the way users talk about behavior. So let's think about what that means for a second. So let's think about a restaurant, right? We might create a restaurant tracking system. That's an actual piece of software we might write. And a restaurant has employees, it has staff, right? So we have an employee list. Every person who joins the restaurant gets added to the employee, and we probably have roles as a security system or a security mechanism in that database. But what happens when we actually want the staff to do something? So as a waiter, I want to place an order. So acting as a waiter, I'm placing an order. I don't need to act as a waiter to get paid, so I don't need the same object to calculate payroll for this person or track time. Right? But I still need to know who the waiter is. I need to know who the person is. I don't want to have tons and tons of copies of this data for all these different purposes. So in the end, I can inject roles when I'm acting as a waiter, when I'm acting as the cook receiving the order, when I'm acting as staff getting my payroll done, right? I can do all this, and we can separate these different concepts. So how do we tie this together? This is where the context comes in. So the purpose, you can think of the context like a director. So our roles are things that we give to our actors. Our actors are our objects. Our context is the director. Our context assigns roles to the actors, and then it tells them what to do. The reason this is useful is because it gives us this single point of entry for a business case, for a scenario, to reason about what's going to happen, to understand our action, our flow. It gives us a quick way to follow through. Okay, the context is placing an order. So I want to be able to understand what's going to happen. Who are the actors that are going to be brought in to place the order? What roles will they be given? And what will those roles do to facilitate interaction between the actors? So that's kind of repetitive, but that's the basic idea there. So let's go back to brew day. So this is what a context might look like if you're doing it in Ruby. The way I tend to like to do it is pass it a list of params, largely because that's usually what comes in to my controllers anyways, but it's also a really convenient way to add different options and concepts to it in an expressive way. So if you ever work with hashes in Ruby, it's really sort of a fun and idiomatic way to call methods in Ruby is to use hashes as a way to describe all the things you're passing through. So we would do this, we would execute it. So what's going to happen is when we initialize this context, it's going to get our actors, it's going to assign it the roles, and we're going to execute that, and the interaction is going to happen. We might wrap this in a transaction because it is a single context. This is probably something that is transactional. It probably, if you're a domain-driven design person, these contexts probably map quite well with your own bounded context because they represent a particular action scenario, which you want to keep that contained. And that's it. I mean, it's really pretty simple. So there's not really much to this. So that's the basic idea. Sort of, generally speaking, all this is sort of a meta layer for object-oriented programming for doing domain-driven design. The way I like to think about it is it's an object decomposition. So you're taking an object that's usually going to have you adding a lot of stuff or extending it through inheritance or some other mechanism. You're decomposing into things that you delegate the responsibility of behavior to. It gives you a lot of flexibility without relying on a lot of more heavier weight approaches. So particularly, what's particularly nice about DCI is it's very, very simple. Like, that was it. I realize it probably didn't seem very impressive after all that, but that's literally it. So a couple of things though, it's essentially a mapping of use cases and scenarios. It fits really well with the BDD workflow, and it's focused on understanding. So when I say why is it important to have a context, why is it important to be able to reason about algorithms, it's because it's really, really important that code is easy to read, easy to understand. It's easy to figure out how things are working so that we can extend it correctly or understand what's already there and reuse the code. Roles are reusable, objects are reusable, contexts are going to be very specific to your thing. So you want to make sure that you understand how the existing things work. And we want to be able to reason about algorithms. So the one thing I do want to say is these concepts are pretty new. None of the languages have really been built with this in mind. There's some discussion about whether languages that support prototypical inheritance might be better for this because of their concept of delegation being more appropriate to that type of extension and also more efficient. As a rule, calling extend on a running object has performance implications in Ruby. If you sort of understand how that works, it kind of screws with the object cache and stuff like that. It's probably a premature optimization problem for most of your scenarios, and the reason being is you're mostly going to deal with context when there is user interaction, when the user wants to do something. You're not going to be dealing with this very often when you are querying a system, and you're probably going to have things optimized for that and caching and other stuff. So you're generally going to be acting on a small number of actors in that case, unless you're doing bulk input, in which case, why are you putting it through MVC? Anyways, like, why are you using your domain for that? So you probably have some data transform you should be using anyways. So most of the time, this probably isn't going to be your biggest concern. The biggest concern you have is maintainability and manageability of the code. All right, so that gives you the basic idea. This is what this looks like. There's a number of talks, and I kind of recommend sort of going through all of them. There was a DCI talk done at QCon, and there were 3 talks given at ORDev. One of them even includes how to do this in Java. So if you're really brave. The resources that I've been using mostly have been Clean Ruby from Jim Gay, which he's actually in the process of writing. It's not finished. So he's actually starting to get into coming up with some more creative ways of doing this in Ruby. It's obviously focused around Ruby that move past the simple extends option and into some other ways, and obviously hasn't gotten there, so I'm very curious to see how he solves it. You can also get lean architecture from James Copeland. James is a bit of a Scrum guy, so you don't have to hold it against him, but he's going to talk about Scrum a lot in this book. I'm not really sure what it has to do with architecture. So, pick and choose from it. I just ordered it, but I've talked to a couple other people, and they've said that the stuff on DCI is really, really good. Covers a couple of different languages in there, so he actually has specific examples in different languages, including, I think, C# and C++. And then there's that original article on Artima where they sort of describe it. And the original article is great to read. It's not where I would probably start just because it was really a starting point for them. It doesn't describe DCI very well. It only gives a couple of C++ examples. So if you really like C++. Anyways, I hope I've kind of, if you've heard about it and you were kind of curious what it looked like and why it was useful, I hope I've sort of, brought you around and you're feeling.
I've got a question or a troll, I don't know which it is, but if you go back to the slide where you've got the guy that comes over to the side.
Oh yeah, the troll, yeah.
Yeah.
Are you going to tell me that you can do this in functional programming?
Well, no, I'm just going to ask. Why not use talking about tasks stuff that's been around for decades?
Like why not actually build functionally and yeah. I kind of agree, and that's sort of where I'm sort of looking at sort of next architecturally. I think one of the problems that I've noted with functional programming, because I played around with it enough to sort of know that it is a mind shift, but it's a worthwhile one. Once you start wrapping your head around it, you can do some interesting things. But you never move away from the need to constantly think about how you're translating these concepts that come quite far outside of how a computer functions, how an algorithm functions, to how the business thinks. So I think it's
the modeling side of it.
It's like when we went at the Erlang talk, when Yuri showed Elixir, I'm like, oh, that's awesome. That was the most awesome thing I saw in all of Erlang, because, well, I think Erlang is really, really cool. The extra boilerplate that you end up being required to do, while it is very clean, it just feels like it makes it harder for you to go, or other people to go back to the code and immediately, just instantly understand exactly what you were trying to do and map that to the mental model. So if you can do that in functional programming, if you can find an easy way to map to the mental model of the user of what they're doing, I think it fits really well. I just think when you're dealing with domain, it's like you almost want something that's almost a DSL, but you'd like it to be built on something that actually has some reasonable performance characteristics. So we're sort of stuck.
Your Ruby or
so maybe Elixir.
It just seems like you just ripped that out and made a function out of it.
I could have, no, I mean this like, as soon as I was done, I could refactor this. But it's funnier this way. So, yeah. Actually, I think I did refactor that once, I hate to admit it, and that was actually what I came up with. That's just, it's possible it was actually clearer before I did that. Sorry, go ahead.
It seems a lot like aspect-oriented programming in a way.
It's related to it for sure.
And if I were to do this in Java, I would use aspect-J.
That's sort of how they do it. There's a couple of other things that are sort of problematic, because obviously you want to be able to call the methods that you're injecting at runtime, which is a little, so aspect-oriented programming, roles are like aspects, but aspects are cross-cutting. They sort of operate automatically, like a logging or do I have permission to do this? So they have expectations of the object's behavior to be consistent, whereas in this case, we're adding behaviors that we're expecting will be there later on. So there's some differences, but yeah, it's harder to do in a static language as a result of, hey, I just want to add these methods to you. No. So
you can do that aspect-J.
Can you?
Yeah.
So I'll have to take a look at that.
Eclipse, the Eclipse framework itself, has some notion of adapters. So you can have an object and then adapt it to another type or another whatever feature extension or whatever it is, which is very similar to this idea. So it's been there for 10 years probably. It might not. I'm not sure about the performance, but probably it does the job.
Yeah. I mean, it's the idea of pluggability. Like, I think there's been lots of things that sort of worked well for extension frameworks and things like that. Like, it's you're plugging in behavior. It's just, I think, I've done a number of things that have that. Like, worked with frameworks that were very extensible. It's just the extensions themselves and the way they work tend to be brittle in and of themselves, and that there's an interface that they have that they work well together with, and you can extend the behavior by bringing that interface in. Like, if you ever worked with Hibernate or NHibernate, or like in the .NET world, Nancy is built really well this way. But in a very fixed, closed box of how this thing is expected to run. It doesn't really let you get outside the box, at least not from what I've seen. Outside of really you're defining your own program. Well, within that program that's now interfaced and extended, Eclipse or something like that, how do you manage the behaviors you want to run in there, like internally to that API, right? Sorry, he's been waiting.
So you talked about how our fat models are getting really fat. And so people with large Rails applications kind of know what sprawls like, uncontrolled sprawls like in a Rails application, an MVC application. What's sprawl like in the DCI kind of application? Where will developers under time constraints take shortcuts? Like, where is it easier to add a line to a method rather than create a new method and so on?
I think it comes from, you've got a lot of flexibility, so it's going to come from also, just to begin with, it'll start with people inconsistently, doing things a little bit different here, a little bit different there, so you end up with, you start getting a very big API because it's very broken up into lots of different contexts and classes, and each one of them will start to work a little bit different. So maintaining that consistency, particularly in a dynamic language, gets a little bit harder because you can add anything you want. And, you know, I mean, in the end though, you're not going to get the sprawl within a class most of the time. You're going to just end up with a lot of files. And it just depends on how you feel about that.
So the complexity would be the composition.
Pardon? Yes.
How about we continue over beers?
Yay!
Okay. Well, I'll come over after, and then we'll, yeah, we can.
Sorry, we're just short on time, and if we go over the mark, then we just end up having a table for the
Hey
menu.
Chris, before you turn that off, can you flip to slide 2? I want to take a picture.
Oh yeah, that's awesome. So just a quick show of hands, who's going to be going for beer? I'm going to say that's about 15.
Well, you got to be in it, Chris.
Okay, we're going to be down in the Revel Room. We're going to try to clear out this place as fast as possible. If maybe 3